Welcome to today's video. This is lesson 7.7 titled Multiplying Polynomials. So before we get started, I'd like you to look at these two problems. And hopefully you can recognize that the addition signs here are separating these terms. So this is a trinomial with three terms, and it's a third degree trinomial. So we call that a cubic trinomial. So because of these addition signs, there's no multiplication going on except right within the term 5 times x squared. So when we have a trinomial and there's all addition signs in between here, we look to add like terms. So notice that 5x squared is not a like term with 4x cubed because the x squared and the x cubed are not the exact same variable component. And 6x is not a like term. So we would say that this is simplified. There's nothing more to do to this expression to write it any simpler. It's simplified. Well, down here I use the exact same terms, but I made a binomial that is all being multiplied by a monomial. So notice by changing this addition sign to a multiplication, it now becomes a very different problem. And hopefully you can recognize that we are multiplying 5x squared because of these parentheses by everything inside the parentheses. So since we are multiplying, 5x squared times 4x cubed really looks like this. We are multiplying this together and we are going to multiply the coefficients. So I grouped the coefficients together to get 20. And then notice when we multiply, we have the multiplication property of powers. When you multiply two powers with the same base, the base stays the same and we add the exponents. So this multiplication becomes 20x to the fifth. I bring the addition sign down. Now when I multiply here, 5 times 6 is 30. X squared times x is x cubed. Then I check. My answer is a binomial, two terms, and I look to see if they're alike. They're not alike, so there's no more simplifying we can do. So now I'm simplified, and my final answer is here. So today's lesson is on multiplying polynomials. So it kind of goes back 2 lessons to all of those rules of multiplication, and it uses the distributive property to apply. So for a couple of examples, in this case, notice there's no addition signs, so that means we are multiplying two monomials together. Okay, so we're multiplying two monomials together. So really what that means is you multiply the coefficients, -3 times 4. Then you multiply all the powers with the same base. X cubed times x is x to the 4th. Y squared times y to the 5th is y to the 7th. So notice a monomial times a monomial just gives you another monomial. We didn't have to use the distributive property here at all. It was just multiplying two monomials together. Okay. So if you can look in your book on page 492, I'd like you to do check it out. 1A, 1B, and 1C. And when you've completed, you can restart. So the next example is exactly like I showed you at the beginning. What do you do when you multiply a monomial times a binomial? Well, just like the previous example, this is an application of the distributive property. So please pause the video and distribute this and then restart it to see if you did it correctly. So when you multiply 4a times a squared b, it should be 4a cubed b plus 8a b squared. Once again, we stop at this point because a cubed b is not the exact same structure as ab squared. So these are not like terms. We can't simplify. we're completely done. So on page 493, please do the check it outs, 2a, 2b, and 2c. And when you're finished, go ahead and restart. Okay, that brings us to one of the most important lessons of Algebra 1, and that is how do you multiply two expressions when you have two binomials. So we're going to start pretty easy, and it looks like this. So we've got a binomial times another binomial. There's lots of ways to think about this, and there's an acronym I'll share with you in just a minute. But what I'd like you to think about is, by definition, if this was just a 3, it meant we had to multiply 3 times all of this. Well, these parentheses mean all of this has to now be multiplied by all of this. So in other words, we do have to multiply 3 over here, but we also need to multiply the x. Okay. So I often call this the double distributive property, because we're going to do the distributive property twice. Okay, so to isolate this, you can cover one up if you want. X times x is x squared. X times negative 4 is negative 4x. I'll cover up the other one. 3 times x is 3x. And 3 times negative 4 is negative 12. So it should make sense to you that if you have two terms here that have to be multiplied by two terms here, you should end up with 4 terms. 2 times 2 is 4. We did 4 multiplications. Well, now we want to look at this and see if there's like terms. And you should notice right in the middle here we've got some like terms. Negative 4x plus 3x can simplify to negative x. The constant of negative 12 has nothing to be added to, and the x squared term is alone. So there's your solution. Okay. All right, so let's do this example. What would you do if you saw something like this? Well, by definition, anything squared means that thing times itself. And if you notice, now we have a binomial times a binomial. Excuse me. So we're going to use the distributive property once, then we're going to do the distributive property twice. So the first term has to be distributed, and then the second term. So when we do this, x times x is x squared. X times negative 3 is negative 3x. Then we move to this term. Negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. So you always want to check, because if you did this correctly, 2 terms times 2 terms should give you 4 terms. So we've got our 4 terms. Now notice the middle 2 terms are alike, so you can add those together. Negative 3x minus 3x is negative 6x. Okay? Alright, we're going to do one more that's a little trickier. Okay, so please pause this video. I want you to try this problem and then restart to see the solution. So to start out, we do 2a times a is 2a squared. 2a times 4b squared is 8ab squared. Negative b squared times a is negative ab squared. And negative b squared times 4b squared is negative 4b to the 4th. So notice that these signs of addition, subtraction, subtraction carried down from whatever the sign of the product was. So in this case, negative b squared times a is negative AB squared, so we put a subtraction sign. Now if you notice, 8AB squared minus 1AB squared can be simplified. So we end up with 7AB squareds, and there's our final solution. Okay. And the last example is what happens when you multiply a binomial times a trinomial. So something like this. Well, it's the same application as before. So we've got 2 terms times 3 terms. So we have 2x that has to be multiplied by everything in the parentheses. So that's going to give us 3 terms. Then negative 5 has to be distributed. So as you can see, you're going to end up with 6 terms. So to start out, 2x times negative 4x squared is negative 8x cubed. 2x times negative 10x is negative 20x squared. And 2x times 3 is 6x. Next expression, negative 5 times negative 4x squared is positive 20x squared. Negative 5 times negative 10x is 50x. And negative 5 times 3 is negative 15. And I ran out of room there. So here's our 6 terms. 1, 2, 3, 4, 5, 6. So we got them all. Now we're scanning to look for like terms. So I see x squared terms are alike, and I see x terms that are alike. So when you simplify this, you get 8x cubed. Negative 20x squared plus 20x squared, those are opposites, so they're canceled. 6x plus 50x is 56x minus 15. So there's our final solution. Okay. To finish up, I'd like you to look on page 496. And in the middle of the top of the page, I'd like you to do 4A and 4B for the checkpoints. And please be ready to jump in. This is have a hard day of working on this bookwork. Have a good night.